Dear students, in this lecture we revise some basic results and solve some examples. So these are some basic important results. Integral of x raised to n equal to x raised to n plus 1 upon n plus 1. Note that here n is not equal to minus 1. Okay, this is all these results are derived from the derivatives. Recall that integral is antiderivative. Okay, so if derivative of x raised to n plus 1 upon n plus 1 is x raised to n, then integral of x raised to n should be x raised to n plus 1 upon n plus 1. Okay. Now here we are not taking n minus 1. So what if n equal to minus 1? Then our function will be 1 upon x. Okay. So next formula is integral of 1 upon x is log of x. Okay. And it is derived from this derivative of log of x is 1 upon x. Note that we are not writing plus c here. Okay. So usually when we take integral of 1 upon x, then we write log of x plus c. Then integral of e raised to x is itself, function itself, e raised to x. Then if we consider real number a, of course positive, then a raised to x, its integral is a raised to x upon log of n. Then integral of sine x is minus cos x. Okay. Remember, integral of cos x is sine x. Then integral of sec square x is tan x. Integral of cosec square x is minus cot x. Okay, so using all these derivative formulas. Integral of sec x into tan x is sec x. Similarly, integral of cosec x into cot x is minus cosec x. Okay. Now, these are inverse trigonometric functions. We know that derivative of sine inverse x is 1 upon square root 1 minus x square, and it is same as derivative of minus cos inverse x. Okay. So integral of 1 upon square root 1 minus x square, it can be sine inverse x, or we can write it as minus cos inverse x. Similarly, derivative of tan inverse x is 1 upon 1 plus x square. So integral of 1 upon 1 plus x square is tan inverse x. Similarly, this is same as minus cot inverse x. Next is integral of 1 upon x into square root x square minus 1 is equal to sec inverse x. It is also equal to minus cosec inverse x. Then these are hyperbolic sine and cos functions. Integral of cos hx is sine hx, and integral of sine hx is cos hx. Now this is important note. Usually we write integral of 1 upon x is log of x. Okay. Here the underlying assumption is x is positive. Okay, because when we consider real valued function logarithm, then its domain is positive real numbers x. Okay, so we cannot take here log of x where x is negative. Okay, it will not be a real number. So underlying assumption is x is positive. Okay. So what happens if x is negative? If x is negative, then of course minus x is positive. Okay, and we can note that derivative of log of minus x equal to, by definition, it should be 1 upon minus x, and by chain rule, differentiation of minus x with respect to x. It is d minus x by dx, that is minus 1. Okay, so simply it is 1 upon x. So it is clear that even if x is negative, integral of 1 upon x dx, we can write it as log of minus x. Okay, so here x is negative. So what to do if we are not sure whether x is positive or negative? Okay, in that case, what we can do is, if x is positive, then absolute value or modulus of x is positive. If x is negative, then mod of x or absolute value of x is minus x. Okay, so just we write this as integral 1 upon x dx is log of mod of x. Okay, so it is better. Now let us solve some examples. Example 1. Question is, find indefinite integrals of following functions. Okay, or question can be integrate the following functions. Okay. First function is x raised to 1 by 3 plus x raised to 1 by 2, that means square root of x. X raised to 1 by 3 means it is cube root, plus x raised to 3 by 5. Okay. Solution. This is our f of x. So we use linearity first thing. So integral x raised to 1 by 3 plus x raised to 1 by 2 plus x raised to 3 by 5 dx equal to, by linearity. Linearity we have seen integral f of x plus g of x dx is equal to integral f of x dx plus integral g of x dx. In fact, if there is a constant, then we can write, say, integral alpha f of x. You must be aware of this rule. Alpha f of x, integral alpha f of x plus beta g of x dx. It is equal to alpha integral f of x dx plus beta integral g of x dx. Okay. So this is what we are using here. Okay, so this is integral x raised to 1 by 3 dx plus integral and so on. Okay. Now we use the rule integral x raised to n equal to x raised to n plus 1 upon n plus 1. Okay. N is not equal to 1 in all these cases. So this is x raised to 1 by 3 plus 1 divided by 1 by 3 plus 1. Okay, we can write directly. Since this is first example, I'm writing each step. Okay, otherwise we can directly take this as x raised to 4 by 3 directly. Okay, divided by 4 by 3 plus and x raised to 3 by 5 plus 1 divided by 3 by 5 plus 1. Now we simplify. This is x raised to 4 by 3 upon 4 by 3 plus x raised to 3 by 2 upon 3 by 2 plus x raised to 8 by 5 upon 8 by 5. And finally, we get this 4 by 3 in the denominator. It is same as 3 by 4. Okay, so 3 by 4 x raised to 4 by 3 plus similarly this 3 by 2 becomes 2 by 3 x raised to 3 by 2 plus 5 by 8 x raised to n by 5. Of course, I should write plus c everywhere when I'm integrating. Okay, so plus constant of integration. Okay, it can be any real number. Okay. Next example. Given function is x square plus 2x plus 3 divided by x raised to 4. Okay. We simplify this so that this is okay. So numerator is addition of 3 functions x square, 2x and 3. So we can take denominator to each of these terms separately, and this is nothing but x square by x raised to 4 plus 2x by x raised to 4 plus 3 by x raised to 4, and on simplification we get this as x square divided by x raised to 4. It is 1 upon x square, or rather we can write x raised to minus 2. Okay, because if we take this this 1 upon x raised to 4 can be written as x raised to minus 4 in the numerator. Okay, so x raised to minus 4 into x raised to 2. Simply it is x raised to minus 2 plus 2. Numerator power is 1, denominator is 4. So 1 minus 4, it is x raised to minus 3. And similarly, here it is 3 into x raised to minus 4. And now we can integrate. So integral x square plus 2x plus 3 divided by x raised to 4 dx equal to, now we directly use linearity. So this is integral x raised to minus 2 dx plus 2 times, okay, this is constant like alpha, beta, okay, we are taking outside. 2 times integral x raised to minus 3 dx plus 3 times integral x raised to minus 4 dx. Now we use the formula of integral of x raised to n equal to x raised to n plus 1 upon n plus 1. So this is x raised to minus 2 plus 1, it is minus 1 divided by minus 1. So divided by minus 1 means simply it is minus sign. Okay, 1 upon minus 1 is minus 1. Then plus 2, x raised to minus 3 plus 1, that is minus 2, divided by minus 2 plus 3 times x raised to minus 4 plus 1, that is minus 3, divided by minus 3 plus c. And this is equal to x raised to minus 1. Here we can cancel 2. Okay, and this will be minus 1 in the denominator. It can be minus sign. Okay, so minus x raised to minus 2. So this should also be minus. And similarly, this is minus x raised to minus 3 plus. Okay, so this is required solution. Next example. Is again similar. Given function is 2x raised to 4 plus 3 divided by x square plus 1. Okay, so this is rational function. Okay, numerator and denominator both are polynomials. Okay, so these are such types of functions are called as polynomial functions. Okay. Now what we can do, numerator degree of polynomial in the numerator is bigger than in the denominator. We try to cancel out denominator in some terms if possible. Okay, so what we can do is, this is x raised to 4 Okay, so x raised to 4 can be x square, its square. Okay, this is first thing. Another thing is what is alpha plus beta into alpha minus beta? It is alpha square minus beta square. Okay, so can we write in this form? Okay, so somehow we can write x raised to 4 minus 1. X raised to 4 means x square, its square, and minus this 1 is nothing but 1 square. So this is of the form alpha square minus beta square. So it is alpha plus beta and alpha minus beta. Okay. So if we can write like this, then we can cancel this x square plus 1 in the denominator. Okay, this is one way. Of course, this example can be solved in many ways. Okay, so one of the ways is like this. So what we do, we write this as 2. I don't have minus 1 here, so I can subtract and add. So x raised to 4 minus 1 plus 1. Okay, so it is same as x raised to 4. This is plus 3 divided by x square plus 1. Now it is equal to 2 times this x raised to 4 minus 1. Then this is plus 2 plus 3, so plus 5 divided by x square plus 1. Now this x raised to 4 minus 1 can be written like this. So 2 times x square plus 1 into x square minus 1 plus 5 divided by x square plus 1. Now we take separate denominator for these two terms in the numerator. So it is equal to 2 times x square plus 1 into x square minus 1 divided by x square plus 1. So this x square plus 1 gets cancelled and we simply have x square minus 1 plus this 5 divided by x square plus 1. Okay, and this is nothing but 2 times x square. This is minus 2 and this is 5 divided by x square plus 1. Okay, now all these terms are easy to integrate. Okay, and now we write therefore. Okay, so first we simplify the integrand and then take integral. Okay, so integral 2x raised to 4 plus 3 divided by x square plus 1 dx equal to this one. We use linearity directly and write 2 times integral x square dx minus 2 times integral 1 into dx plus 5 times integral 1 upon x square plus 1 dx. And these things are easy. So it is 2 integral x square, so it is x raised to 3 by 3 minus 2 times integral 1, it is nothing but x raised to 0. X raised to 0 is constant, so integral of 1 is x plus 5 times integral 1 upon x square plus 1. We just have seen that integral of 1 upon x square plus 1 is tan inverse x. Okay, so tan inverse x plus constant of integration. Okay, so this is required answer. Next example is number 4. It is square root x plus cube root of x square bracket square divided by x. Okay, it looks difficult, but it is not. Okay, so what we can write, we need to simplify. Okay, so first thing is root x. Okay, so we write it as root x, or it may be x raised to 1 by 2, that doesn't matter. Okay, plus what is cube root of x square? Cube root of x square is, it is x square raised to 1 by 3, means x raised to 2 by 3. Okay, so if it is square root, it is raised to 1 half, cube root raised to 1 by 3, and already there is square. Okay, sorry, square root of x square is there, na? So it is square root of x raised to 2 by 3. Okay, but let me write this as, what is square root of x square? Cube root of x square, it is nothing but x square raised to 3 by 2. Okay, cube root means, sorry, wait. This is square root of x square raised to 1 by 3. Okay, square root of, just a minute, not square root, it is x square raised to 1 by 3. Okay, fine. Okay, if I'm writing like this, nth root of x, then it is nothing but x raised to or nth root of y equal to y raised to 1 by n. Okay, maybe square root, we don't write 2 here. By default, it is square root. So here it is n, then it is y raised to 1 by n. And now my y is x square and n is 3. So this cube root of x square, it is equal to y is x square and raised to 1 upon n, so 1 by 3. And now these are powers. Okay, power of power, so it is multiplication. So x raised to 2 into 1 by 3, so 2 by 3. Okay, so it is here x raised to 2 by 3. Okay, this bracket square divided by x, and now it is of the form a plus b bracket square, and we can expand and get a square plus 2 times a into b plus b square. Okay, so it is square of this. So square root of x, it's square, it will be x plus 2 times product of these two things, x raised to 1 by 2, x raised to 2 by 3, plus square of second thing. So x raised to 2 by 3, it's square, and divided by x. Now simplify once again, so that this will be x raised to 1 by 2 multiplied by 2. Okay, so x raised to 2 by 2, it is x plus 2 times, we can add these exponents. Okay, so x raised to 1 by 2 plus 2 by 3, so it is 5 by 6, plus this is power of power, so it is x raised to 4 by 3, 2 into 2 by 3, x raised to 4 by 3 divided by x. Okay, so we can take separate denominator for each term, and now write x divided by x is 1 plus 2 times x raised to 5 by 6, x in the denominator, so we subtract 1 from this power. So 5 by 6 minus 1. So it is 5 minus 6, that is minus 1 by 6. Okay. So minus 1 by 6. Okay. Then plus same thing here. So 4 by 3 minus 1. So 4 minus 3, that is 1 by 3. Okay. So this is simplification. And now rest is straightforward thing. Okay. So therefore integral square root x plus cube root of x square bracket square divided by x dx equal to directly here integral of 1, it is x plus 2 times integral of x raised to minus 1 by 6 is x raised to minus 1 by 6 plus 1. So it is x raised to 5 by 6 divided by 5 by 6 plus x raised to 1 by 3 plus 1, that is x raised to 4 by 3 divided by 4 by 3 plus constant of integration. This can be simplified further. So x plus, this is 6 2s are 12 by 5 x raised to 5 by 6 plus 3 by 4 x raised to 4 by 3 plus c. Okay, that's all. Now we solve some examples containing trigonometric functions. Okay, so next example, fifth, is 1 upon cos square x. Okay, it is not difficult thing because we know that 1 upon cos x is sec x, and since there is square, so it is nothing but sec square x, and we know this integral. Okay, therefore integral 1 upon cos square x dx equal to integral sec square x dx, and it is nothing but tan x, because derivative of tan theta is sec square theta. Okay, so plus c. We can use this to find another thing. Wait. So it is homework. So find this integral 5 times cos x minus 3 times sin x minus 2 upon cos square x dx. Okay, so all other terms are straightforward things. Okay, we know integral of cos x is sin x, integral of minus sin x is cos x. Okay. Next. Next function is 1 plus 2 sin x upon cos square x. 1 plus 2 sin x upon cos square x. So what we do here, we take separate denominator. So it is 1 upon cos square x plus 2 times sin x upon cos square x. Okay. Now 1 upon cos square x, it is sec square x plus 2 times. This we write as sin x upon cos x. Okay, denominator is cos x into cos x. So one term is sin x upon cos x, that is tan x into 1 upon cos x. So 1 upon cos x is sec x, And now we can find integral easily. Okay, therefore integral 1 plus 2 sine x upon cos square x dx equal to, by linearity it is integral sec square x dx plus 2 times integral tan x into sec x dx. Now these are standard results. Okay, so this is first thing is integral sec square x, so it is tan x and plus 2 times, this is integral sec x into tan x, it is sec, integral is sec x plus constant. Okay, next is phi cos cube x plus 7 sine cube x divided by 2 times sine square x into cos square x. Okay, so same strategy. So it is 5 by 2 into cos cube x upon sine square x cos square x. So this cos square x gets cancelled and we just have cos x upon sine square x plus this 7 by 2 sine cube x divided by sine square x cos square x. Again sine square x gets cancelled and we just have sine x upon cos square x. And now it is phi by 2 and again cos x upon sine x, it is cot x into 1 upon sine x, it is cosec x plus 7 by 2. Similarly, sine x upon cos x is tan x and 1 upon cos x, it is sec x. And this thing again is standard. Okay, so therefore integral of this function, let me call this as g of x, so that integral g of x dx equal to, this is 5 by 2 integral cot x into cosec x, so it is minus cosec x, so minus sign is here, plus 7 by 2 into integral tan x sec x, it is simply sec x plus c. Okay, so this is the required answer. Next example. Our given function is tan square x. So how to integrate this? Okay, so we know that 1 plus tan square theta is sec square theta. So tan square x can be written as sec square x minus 1. And this we can integrate. Okay, we know integral of sec square is tan x. Okay, so therefore integral tan square x dx equal to integral sec square x dx minus integral dx plus c will be there in the next step. So this is tan x. This is minus x plus c. Okay. Next is again ratio of cosine functions. 1 minus cos 2x upon 1 plus cos 2x. Okay. Now we know the double angle formula, cos of 2 theta equal to 2 cos square theta minus 1. Okay, we are going to use this thing. Of course, there is another formula that we are not going to use here. Cos of 2 theta equal to 1 minus 2 sine square theta. Okay, this we are not going to use. Okay, we use this one. Okay, so what will be our numerator? 1 minus cos of 2x, it will be minus 2 cos square x, and this will be plus minus sign here, and here it will be plus 1. In the denominator, it is 1 plus cos 2x. So it is simply 2 times cos square x. Okay. So numerator is 2 minus 2 cos square x upon 2 cos square x. We can cancel 2, and it is 1 minus cos square x divided by cos square x. Okay. And simply it is 1 upon cos square x minus cos square x upon cos square x, that is 1. Now we can integrate, because 1 upon cos square x is sec square x. Okay, and this is straightforward. Okay, so therefore, if I am calling this as g of x, then integral g of x dx equal to integral sec square x, that is again tan x, integral of minus 1, that is x minus x, of course, plus. Okay, so this is the required answer. Next example is again double angle thing. So our function is square root 1 plus sine 2x. Okay. Now there is double angle formula. Sine of 2x is 2 sine x cos x. But it is not of any use here. Okay. If there is square root, we want to get rid of that square root. So here sine 2x double angle formula is not of use directly. Okay, but there is another thing. So representation of this 1 is important. Okay, so we use 1 as sine square x plus cos square x. Okay, because we know sine square x plus cos square x is 1. Okay, so this step is very important. So I'm writing 1 as sine square x plus cos square x. Okay, and sine 2x, I'm writing sine of 2x is 2 sine x into cos x. Now what is this? This is of the form a square plus b square plus 2 times ab. So this is nothing but a plus b bracket square. A is sine x, b is cos x. So sine x plus cos x bracket square, and this is nothing but sine x plus cos x. Now things are not difficult. Integral square root 1 plus sine 2x dx equal to integral sine x dx plus integral cos x dx, and integral sine x is minus cos x. Integral cos x is sine x plus. Okay. If it is cos 2x instead, then things are quite simpler. Okay. So if it is square root 1 plus cos 2x, then it is not that difficult, because we know cos of 2x as 2 cos square x minus 1. So it is square root 1 plus 2 cos square x minus 1, so that we can cancel this one, and this is nothing but square root 2 cos square x, and it is nothing but root 2 into cos x. And now integral is root 2 constant, integral cos x, it is sine x plus. Okay, that's all. Okay, so there are some other examples shared with you. Please try to solve these examples. In case any doubt, you can ask me. Thank you.